Okay, so in this video we will look at tan delta test or the electric dissipation factor test. This test is usually called as tan delta test, TD test, so very common electrical test performed on an insulation of high voltage equipment. So tan delta test or dissipation test is basically to check on the condition of the insulation, okay, insulation material, because the insulation of an electrical equipment is essential, very important for secure and reliable operation of not just transformer, other electrical equipments as well. So by measuring the capacitance of the insulation or the dissipation factor of the insulation or the tan delta of the insulation, okay, this will help us to determine the condition of the insulation. Alright, not just the transformer, not just the insulation between windings, basically any insulation in electrical high voltage equipment, we need to measure or we need to assess, evaluate the insulation condition. And one of the method we can do this is to measure the tan delta, the parameter of the electrical power parameter that need to be measured is tan delta. Alright, so we will look at the next slide. What is tan delta? So I mentioned about the capacitance. So any changes in the capacitance, okay, will indicate mechanical displacement. I'm sorry, let me fix that, let me change that. Any changes in the capacitance, okay, as an example, can indicate mechanical displacement of winding or partial breakdowns in bushing. Alright, because capacitance itself consists of, you can see in the figure here. Alright, so the figure shows two, let me move this. Right, so the figure shows two metal plates, okay, and we have dielectric material in between. Right, so dielectric material is basically insulation material. Okay, so we have insulation material and compressed or sandwich, okay, by two metal plates, two conductive plates. Alright, so we have a typical capacitor here. So if the dielectric material, the properties of the dielectric material or the insulation changes, it means that the capacitance also change. The value of capacitance will also change. Right, so aging, right, we go back here, aging and degradation of the insulation. Okay, so we have the insulation, the aging of that material, okay, and also water, ingress of water inside the insulation material can cause changes to the capacitance, the total value of the capacitance. Alright, so any losses in the insulation material can be measured as dissipation factor, or the besides dissipation factor, we could also measure the changes of the capacitance. Right, so the capacitance changes, the value of the capacitance changes, means that the insulation material has changes, aging, degraded, or whatever. Several factors has happened to the insulation. Right, so with our testing system, the tan delta, basically you can determine, okay, with tan delta test we can determine the capacitance and also the dissipation or power factor at variable frequency. So this is actually taken from from a reference. Basically, when we measure the tan delta, we can measure at various frequency. We supply voltage to measure the tan delta. So the supply voltage can be at 50 Hertz, 60 Hertz, 100 Hertz. So we can basically change the frequency and observe the different behavior of the insulation at different frequency. But basically the idea of tan delta is to measure the parameter of the insulation. Okay, changes of the, if any value, sorry, if the capacitance or the tan delta value changes, means that the insulation material has changed, right? Okay, so that's the idea. We need to, because the main reason we do this test is to monitor or to evaluate or to assess the condition of the insulation. Is the insulation condition is still good, or has it deteriorated? Alright, so that is what we want to do with tan delta test. Basically, we want to evaluate the condition of the insulation. Okay, so tan delta, also known as a measurement of the dielectric loss or dissipation factor. So we have several terms here that you need to take note on, right? Dielectric loss or dissipation factor, tan delta, power factor, even power factor. We will go to that later on. But take note on these terms. They are basically, the concept is the same. All right. So on account of the dielectric loss, the current through the capacitor does not lead the voltage across it by 90 degree. Okay, means that okay, look at the, okay, we still have the figure, the same figure here, capacitor. All right, we have two metal plates, conductive plates, and in between we have the insulation material, and we have terminal plus and minus, right? So this can be represented as C. Okay, single symbol of C is capacitor, right? However, if the insulation material has some dielectric loss, leakage current, so if we supply high voltage, right? So let's say 100 volt or 500 volt, and this is ground, and somehow we can measure leakage current flowing through the insulation material. That is the leakage current, right? So that is basically the dielectric loss because of the imperfect of the insulation. The insulation is not perfect. The insulation has some loss in it. So that loss is represented as IR. That is the leakage current, the resistive current. Alright, this is basically represent the loss of the capacitor. Alright, so because of that small loss, okay, usually the value is very small. Because of that small loss, we can represent in Phasor diagram like this. Okay, so this is the voltage, and okay, so if for a perfect capacitor, okay, for a perfect capacitor, the current will lead the voltage by 90 degree, right? Current will lead, okay, current will lead the voltage by 90 degree. That is for perfect capacitor, 90 degree. However, because of the loss, very small loss, the current, the total current is no longer 90 degree. It will be like, just for example, 89 degree or 85 degree. Alright, not 90 degree anymore. So that small degree, small angle is represented by delta. So that is why we call tan delta. That delta is the angle represent representing the loss. Right? If there is no loss, then the current will be here, 90 degree with the voltage. However, there is a loss because of the IR, okay, because of the imperfect of the capacitor, because of the aging, because of the deterioration of the material, right? Because of that, it is no longer 90 degree. It has moved to towards here, right? So we have like small angle here that is called delta. All right. So the tan delta is basically the tan delta is IR over IC. Right. Tan delta is basically ratio of IR over IC. Alright. So this is IR, this is IC. Right. So another equation for tan delta is 1 over omega times Cp times Rp. Okay. So basically you can derive this. Okay, tan delta equals IR over IC, and then from that you can see that IC is basically omega Cp times U. Okay, this is the U, voltage across the capacitor. IR is also U over Rp, right? Basically the value of the current for resistor and capacitor, which is basically represented by the voltage and the frequency as well, right? So this is the concept of tan delta. Alright, tan delta basically represent the dielectric loss. Okay, so meaning if tan delta value is very high, means that the loss is very high. Okay, so this is basically what I have mentioned earlier. Right, so an ideal capacitor, perfect capacitor without any losses, insulation current is exactly 90 degree leading the voltage. Alright, but however real insulation there will be very small loss. Okay, so the angle is no more not 90 degree anymore, it is less than that. So the insulation of any high voltage equipment, okay, can be modeled by a loss-free capacitance with a parallel ohmic resistance representing the losses, which is IC in parallel with IR, or C parallel with R. Alright, so the ohmic resistance, okay, that IR, the loss represented by the Rp here, this is the loss. Okay, ohmic resistance is caused by surface currents, leakage currents, partial discharges, polarization losses. So these are all basically like the theory or the mechanics or what happens in the insulation, right? What happens in the insulation that causes the loss are because of currents flowing through the surface, leakage currents, partial discharges happens in the insulation, polarization of the molecules inside the insulation also causes some losses, right? These are all the physics in the insulation that causes the loss, right? Okay, so not to confuse between tan delta and power factor. So these two terms are also commonly used. You probably you definitely have come across power factor before. Alright, but in terms of tan delta or power factor in electrical test of on the insulation, right? For power factor usually used in North America. Okay, so if you go to the IEEE standards on any high voltage equipment, okay, they will use power factor. Power factor is the term they use to evaluate that loss, to measure that loss. However, for us, we refer to the British standard, we will also which also refer to the IEC standard. For IEC standard, we use dielectric dissipation factor, which is also tan delta. Alright. So the definition is slightly different. Okay. However, the value does not change mass. Alright. Quite similar, very almost similar. Alright. So for example, okay, power factor is basically cos theta. Alright, cos theta, which is, in this case, theta is the other angle. This is delta, this is theta. So power factor basically refers to this angle instead of delta. Okay, power factor refers to the theta. Alright, cos theta, which is basically IR over I. Alright, IR over I. For tan delta, it is IR over IC. Alright. Okay, so the dissipation factor or tan delta is an indication of the state of dielectric material, indication of the condition, okay, of the insulation, right? Like I said, if the tan delta value is bigger, is larger, then the insulation condition is worse. Okay, tan delta value large tan delta value, okay, the I will move towards here, then the loss is bigger. Alright, worse the insulation condition. Prone to conduction, meaning that it has more leakage current. Also indicates that damage has occurred, such as carbonization in the insulation, void in the insulation, electrical treeing. Okay, so these are indication of when we obtain high tan delta value. Okay, any variation coupled with different values and sudden change in the tan delta value with applied voltage is an indication of the onset of internal discharge. Okay, this is quite important, quite interesting. So you can see here, this is the tan delta value, dielectric loss value. So if the tan delta, if we increase the supply voltage, okay, you can see here, if we increase the supply voltage of the tan delta test, perform the tan delta test, we have to inject AC supply. Okay, so if we increase the AC supply, the test voltage, the tan delta value will also increase. Okay, but if at high voltage the increment is very high, okay, exponential, then that will indicate, that usually indicate internal discharge in the insulation or partial discharge. Okay, see here at high voltage, okay, at high voltage, if the tan delta increase exponentially, that is usually indicate the ionization loss, means that partial discharge has occurred in the insulation material, right? One of the commonly used method for measurement of capacitance and dissipation factor tan delta is the high voltage shearing bridge.